Title: Reproducibility Study of ITI-GEN, Inclusive Text-to-Image Generation. Abstract: This study aims to reproduce the results presented in ITI-GEN, Inclusive Text-to-Image Generation, by Zhang et al. 2023a, which introduces a model to improve inclusiveness in text-to-image generative models. The authors claim that ITI-GEN improves the diversity and quality of generated images, is scalable to different domains, has plug-and-play capabilities, and is efficient from a computational point of view. However, ITI-GEN sometimes uses undesired attributes as proxy features and struggles to disentangle some pairs of correlated attributes such as gender and baldness. This study verifies these claims and proposes using hard prompt search with negative prompting to solve these issues. Introduction. Generative AI models that solve text-to-image tasks pose societal risks related to fairness due to training data biases. Zhang et al. 2023a introduce inclusive text-to-image generation, ITI-GEN, a method that generates inclusive tokens that can be appended to text prompts to ensure diverse images with respect to predefined attributes. Scope of reproducibility. The authors make several claims about ITI-GEN, including its ability to improve inclusiveness while preserving image quality, scalability to different domains, plug-and-play capabilities, data and computational efficiency, and scalability to multiple attributes. This study aims to verify these claims through experiments and also studies failure cases of ITI-GEN and proposes alternative methods that handle negations in natural language. Methodology. The authors provide an open-source implementation on GitHub, which was used as the starting point for this study. Bash scripts were designed to make the experiments reproducible. The integration of ITI-GEN with ControlNet, Zhang et al. 2023b, was also implemented to check the compatibility of ITI-GEN with other generative models. ITI-GEN is a method that improves inclusiveness in text-to-image generation by outputting a set of fair tokens that are appended to a text prompt to guide the model to generate images in a certain way. The model uses reference images for each attribute category and learns a set of fair tokens that represent each attribute category. The training procedure involves two losses: the directional alignment loss, which relates the provided reference images to the inclusive prompts, and the semantic consistency loss, which acts as a regularizer by making the original text prompts similar to the inclusive prompts. The directional alignment loss is defined as the difference between the average of image embeddings between categories of an attribute, and the difference between the average of embeddings of inclusive prompts corresponding to those categories. This loss is replaced by a cosine similarity loss when it is undefined. The semantic consistency loss makes the original text prompts similar to the inclusive prompts. At inference, the output of the generative model reflects the attribute categories of the fair tokens. Sampling over a uniform distribution over all combinations leads to fair generation with respect to the attributes of interest. The text prompt can be the same as used for learning or different. ITI-GEN is compared to HPS, which works by specifying the categories directly in the original prompt. However, HPS does not handle negation properly, and using a prompt like, "a headshot of a person without glasses," will actually increase the chances of getting someone with glasses. This can be circumvented by using the unconditional _ conditioning parameter, which is hard-coded to take in the empty string in the current stable diffusion sampler. The authors provide 4 datasets of reference images to train the model: Celeba, Fair, Fairface, and Landscapes HQ. The hyperparameters used to reproduce the results of the original paper are provided, and the code used to replicate and extend the experiments is available on GitHub. The experimental setup and code are also described, including the implementation of ITI-GEN with ControlNet to validate its plug-and-play capabilities with other text-to-image generation methods. The research paper evaluates the ITI-GEN model, a text-to-image generation model, focusing on its inclusiveness, image quality, and scalability. The authors investigate the model's performance across various attributes using the Celeba dataset and compare it with HPS and HPSN models. ITI-GEN outperforms HPS in terms of FID scores, suggesting better image quality, but human evaluations show a preference for HPS in 52.24% of the cases, highlighting a discrepancy between the FID scores and human perception. The study also demonstrates ITI-GEN's scalability to different domains and its plug-and-play capabilities with similar prompts. ITI-GEN is designed to generate diverse images based on textual descriptions. Experiments involving different domains such as human faces and natural scenes demonstrate the model's capabilities. The model's compatibility with ControlNet was tested, showing that it improves diversity with respect to the inclusive tokens used but may introduce other biases from the reference images. Scalability to multiple attributes was tested, revealing that while the KL divergence is low when using 2 attributes, it increases significantly when adding more attributes. This suggests that ITI-GEN's claim of scalability is not entirely correct. Further investigation into this observation is conducted qualitatively and quantitatively, highlighting more pitfalls of ITI-GEN. The model might use proxy features while learning inclusive prompts for certain attributes, leading to strongly coupled attributes and inaccurate image generation for all elements in the joint distribution. Here is a combined summary of the 4 pages. Proxy features in image generation models, such as ITI-GEN and HPSN, can lead to unintended consequences, where models learn to generate images based on attributes other than the intended ones. For instance, ITI-GEN uses gender as a proxy feature when generating images for the bald attribute, resulting in biased outputs. This issue is resolved by using HPSN with negative prompting, which accurately generates bald women. The paper highlights the challenges of handling multiple attributes and diverse image generation, where ITI-GEN struggles to generate diverse images, particularly with attributes like age and eyeglasses. In contrast, HPSN reliably reflects all category combinations. The authors propose combining ITI-GEN with HPSN to leverage their strengths, achieving a KL divergence close to 0 and a FID score comparable to ITI-GEN's. An ablation study on the diversity of reference datasets for the eyeglasses attribute demonstrates that the choice of reference images is crucial, as the model might not learn what is expected but rather the most salient difference between the datasets. The computational complexity of ITI-GEN is also discussed, with linear complexity with respect to the size of the training set, quadratic complexity with respect to the number of categories within an attribute, and exponential complexity with respect to the number of attributes. The paper questions the validity of claims made about ITI-GEN's capabilities, highlighting its limitations in scalability to multiple attributes, requiring exponential training time and often failing to disentangle certain attributes. HPSN is proposed as an alternative, which does not require training and produces more accurate images. The importance of considering potential risks and biases in ITI-GEN's use, particularly regarding data privacy and inclusiveness, is emphasized. The paper presents the development of ITI-GEN, an inclusive text-to-image generation model designed to address bias in image generation. ITI-GEN is trained on a diverse dataset and utilizes a novel approach to ensure balanced representation across different attributes. The model's performance is evaluated using KL divergence, which measures the difference between generated images and the target distribution. Results show that ITI-GEN outperforms baseline models in terms of diversity and inclusiveness, particularly for attributes like gender, hair color, and facial features. The model also demonstrates compatibility with ControlNet, another text-to-image generation model. The paper provides an extensive list of references, highlighting previous work in machine learning, artificial intelligence, and computer vision. This includes research on diffusion models, vision language models, and the quantification of carbon emissions in machine learning. In conclusion, the paper presents a significant advancement in the field of text-to-image generation, focusing on the critical issue of bias and inclusivity. The development of ITI-GEN contributes to the creation of more diverse and representative images, which is essential for various applications in computer vision and beyond. The research also discusses ITI-GEN's ability to generate diverse images based on specific attributes such as skin tone, age, and facial features like beard and mustache. It showcases improved diversity in images generated for different conditions and presents examples of proxy features used by ITI-GEN. The results indicate that while ITI-GEN struggles to generate women with beards, it performs well with the combination of gender and mustache. The study emphasizes the model's low data requirements, showcasing improvements using only a few reference images. Overall, the research demonstrates the ITI-GEN model's capabilities in generating diverse images based on various attributes, highlighting its strengths and limitations in specific areas. The study, published in Transactions on Machine Learning Research, investigates the impact of reference dataset size on improving diversity in generated images using ITI-GEN. It explores how varying the number of reference images affects attributes such as age, skin tone, and colorfulness. Figure 11 illustrates the results, comparing diversity achieved with different sizes of reference datasets 10, 25, and 50 images. The findings suggest that ITI-GEN can effectively enhance diversity even with a limited number of reference images. For the age attribute, diversity improves significantly with a larger dataset, indicating comprehensive coverage of age-related features. In contrast, skin tone shows a significant improvement with just 10 reference images, highlighting ITI-GEN's effectiveness in capturing diverse skin tones. The colorfulness attribute, tested on natural scenes, also demonstrates an increase in diversity with a larger dataset, suggesting better understanding and generation of colors and textures. Overall, the study highlights the potential of ITI-GEN to improve diversity in image generation tasks, particularly with limited datasets, which could have significant implications for applications requiring diverse and inclusive image datasets.